I'm Bill Mulligan. I'm here from Ludsa, and we help companies create an enterprise-grade Kubernetes platform that fits their needs for governance and flexibility. But what we're really here to talk about today is the business benefits of Kubernetes. And so I actually just saw this Dilbert cartoon this morning, and I was like, I have to put this in my slide deck. And so obviously you got the manager guy coming in, he's like, I need to know why moving our app to the cloud didn't automatically solve all of our problems. Dilbert goes back, you wouldn't let me architect the app to be cloud native. And then the manager comes back, yeah, just put it in containers. And then Dilbert's like, no, you can't just solve problems by saying techie things. And then Kubernetes. So I'm sure this is a problem other people have run into before. That there's, in this whole cloud native ecosystem, there's a lot of words that a lot of people don't understand. And so the traditional thing is it's the divide between the dev and the ops side. If we could just kind of bring them closer together into this whole DevOps thing, that would really solve all of our problems. But I think the bigger problem is actually going back to the Dilbert cartoon, is actually between the people who actually code and the people who don't code, between the tech side and the actual business side, between the coders and the management, and how do we bridge that divide? And I would argue that that's the bigger problem. And what this creates is a large problem for small companies, but even greater as you get to larger enterprises where you have huge parts of the companies that don't understand what the IT people do, even though it's central to what every company does today. And so that's what this talk is today. How do we explain the benefits of Kubernetes without any code? And so first we're going to jump into what are we actually dealing with here? How do we get here? What is Kubernetes? And what comes next? And so a little bit about me and why I'm qualified or unqualified to talk about this is you can see the picture on the left there. This is me growing up. I was a scientist. I got my bachelor's in biochemistry. Then I took a little side trip into bike racing, followed finally by a master's in social science. Now, at no point is there any coding in there. So if there is coding in the slides today, I don't understand it because it's not in any of my background. So when I was graduating with a master's in social science, I was like, okay, I need a job because people with social science maybe don't get them. And so when I got the job offer from Ludsa, I was really, really excited. I was like, okay, job offer, let's take it. And they're like, yeah, you're going to be working on this thing called Kubernetes. I was like, wow, first job, I get to head out to these Greek islands. This is going to be a great job. And they're like, yeah, but we also work on this thing called cloud native. And I was like, okay, climate change, maybe not so good. Maybe I can stick with the Greek island side of the business a little bit more than the climate change. But then I sat down on the first day, and they gave me this definition of Kubernetes, and they're like, this is what you're actually doing. And so I read it, and I was like, okay, Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitate both declarative configuration and automation. I was like, I guess this isn't a Greek island. This job will be a little bit different than I thought. And then they slapped down the cloud native definition. Cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds, containers, service meshes, microservices, mutable infrastructure, and declarative APIs exemplify this approach. These techniques enable loosely coupled systems that are resilient, manageable, and observable. Combined with robust automation, they allow engineers to make high-impact changes frequently and predictably with minimal toil. So at the end of that, I was a little bit confused about what was actually going to be happening. And so then, obviously, the first thing I did is start to Google things. And thankfully, Google also made Kubernetes, so it made it a little bit easier to find out what it's actually about. So the first thing you read, okay, Kubernetes is Greek, meaning helmsman or pilot, and it's the root of the word governor. And so a little side note, my company, Ludsa, is actually Plattdeutsch, which is around the region of Hamburg for harbor pilot, because what we do is manage a lot of Kubernetes clusters. So Kubernetes steers one ship, we steer all the ships, whatever, not important. Look into it a little bit more. Kubernetes is one of the most popular open source projects right now, 42,000 stars on GitHub. I think this is actually old, it's over 50,000 now. It's the widest discussed repository by a large margin, like super popular, super exciting to be a part of. And it's all managed by this cloud native computing foundation, which is kind of this vendor neutral governance group for not only Kubernetes, but a lot of other cloud native projects. And so now that I had that little background of like where Kubernetes came from, and kind of like talk about it, I'm like, okay, this makes a little bit more sense. It's like super exciting project, comes from Google. You know, I can tell my parents about that now. I was like, okay, how do we actually translate like this, what this code is, into like actual business benefits? And so the business benefits I'm going to talk about today are, I think, what every single business is based on. Providing a good or service to their customers in a way that's either better, faster, or cheaper than the customer can do it themselves. So at every point in this presentation, you can look for these colors, and we'll be going back to better, faster, or cheaper for your customers. And so we're going to start out with a little working definition. So what is business Kubernetes? Kubernetes is the governor, because that's the root where it came from, of cloud native IT. And what I'm going to be seeking to kind of prove today is what this definition is. What is business cloud native? So cloud native technologies help businesses build modern software that delivers a good or service to their customers. These technologies and they'll allow them to create better system that allows engineers to make changes faster at a lower cost. So before we can jump to Kubernetes, I think we need to rewind the script a little bit and go back to how do we actually get to this whole cloud native thing? So in the olden days, we had a single software application need to be hosting on a single server. So we have a software application and a server. So now the analogy I'm going to be making today that you can actually explain to people that are outside of IT is a person and a house. So I think most people probably want a roof over their heads tonight. I know, like I do. So you have a person that needs to be hosted in a house. Okay, and we're going to be going down the hosting continuum. So on the housing side that most people you can walk up to on the street will understand is we're going from home construction to renting to apartment to flat share to hotel. Where on the cloud native side, we're going from a data center to cloud to virtual machine to container to serverless. And as we move from left to right on this continuum, we're going to be making systems that are simpler, more agile, and more dense. As we said before, these types of cloud-native technologies allow us to create better systems that allow engineers to make changes faster at a lower cost. So, all the way on the left, we have a data center. And this is your classic like home construction project. You can customize it exactly to you want, like down to the color of the wires. You can stack everything how you want, make it look really nice, neat, and pretty. And what does this allow you to do? It allows you to have complete isolation. You can air gap the whole data center if you want to. Customization, build it exactly what you need. And you have complete control over it because you have control over every single part of it. Now, there's a couple of problems with this when you're building your own. I think this picture on the left is one of my favorite. There's a deer in a data center. If you own and build your own data center, that deer is now your problem. If the deer gets in there at 2 a.m., that's your problem. It's not AWS's problem. It's not anybody else's. So you're going to be chasing deer, and that's now in your job description. It's also not that fast to build things. If you want to build your own house or build your own data center, it's probably going to take a couple of years, and you have to pay all that up front. So it's a huge capital expenditure up front. So how can we improve each of those? So the next thing we went to was the cloud. It's not mine anymore. I'm just renting it from someone else. So on the housing side, this is like your classic like landlord. So I live in Berlin. I'm renting from a landlord right now. It's great. And the same thing, that's when the public cloud first started. Your AWS, your Azure, your Rackspace, wherever you want to go. And so what improvements does it allow us to have? Well, first, the data center is no longer yours. If that deer gets in there, it's AWS's problem. It's not yours. Okay, so great. You can sleep through the night. Second part, it's a lot faster. Like they probably have like excess capacity already in there. And so rather than having to wait around to build a whole data center, they have extra machines in there that you can just probably have. So we're going a lot shorter time. And the other thing is when you're renting, instead of having this capital expenditure up front of this huge cost, you're just paying monthly. So I pay my rent monthly. So you're going from, rather than a capital expenditure, to an operational expenditure. So it's getting cheaper for us. But there's still like some problems with just like a mere rental. And so it's still like a manual process. So when I wanted to like move into my flat, I'd like, kind of like carry everything in there, like move out of the old one, move into the new one. Like took a lot of time. It's still not very fast. It took a couple days for me to move. Same thing, like if you're just like renting in the cloud. In the olden days, if you want a new server, you'd like create a ticket, and like they'd like give you a new machine. They're like, okay, here it is. And you still have kind of like these dedicated costs of like these big machines. Like how can you make that cheaper? So the next thing we went to is kind of like splitting up that space to, let's say, a furnished apartment on the right. Or a virtual machine with configuration management on the left for hosting. So what's the great thing about a furnished apartment is taking this like really big machine and cutting it down into smaller slices that are configured towards what you want. So in the same like big building, you can have like a family, you can have like a single studio apartment, and it's furnished, so you don't have to worry about like going in there. You can move in the next day and the bed's already there. Everything's already configured for what you want. Great thing about virtual machines, you can slice up these bigger physical machines into smaller things that are more fit to your application's need. And with configuration management, you can go in and with a button, then your machine is set up exactly how you need it. Okay, so great. So we switched from this manual setup process to kind of an automated process that gives you like really consistent things that are ready for you to move in right away or to use the machine right away. It's a lot faster because you're kind of automating all these processes. So from like a couple days to like, I don't know, now you like click on the Amazon API or like call the Amazon API, you get a virtual machine set up how you need, let's say like 10 minutes, maybe slow. And you're going from like this dedicated cost of like you're renting like this whole big machine down to like Amazon does per second billing. Like, okay, great, better, faster, cheaper. But can we do this any better? The problem with like a furnished apartment is like you still kind of, if you have all these people living in one space, you can kind of have like clashing dependencies. With a virtual machine, you can only run one version of an application at a time. Can we do better than 10 minutes? And it's still only kind of like a single use. And so that's when we came up with the concept of containers, or as I like to say on the hosting side, like a flat share. So you have a whole bunch of people that each have their individual rooms to have their own kind of like life, personalities, and preferences, while they all share the same common space. It's the same way with a container. You can have a whole bunch of containers all sharing the same host operating system and the same underlying infrastructure, while the containers can each run different versions of apps or like be independent of each other. And so what does that provide us? It provides us a better separation of dependencies. Each application or each person has like their own space. Containers are really small and lightweight, so they spin up in average of half a second. And because you can pack people a lot tighter together, you can really increase your utilization. So some people claim they've seen CPU utilization go from like 15% to 80%. Okay, so better, faster, and cheaper once again. But can we do this even better? Like, so if I'm moving into a flat share, I still have to set that up. Like if I wanted to move into a flat share tonight, I like flew into Warsaw this morning, like that would still be a problem for me. And the problem is like you're always like paying for that. So right now I'm in Warsaw, I live in Berlin. I'm still paying for my apartment in Berlin, even though I'm not sleeping there tonight or tomorrow night. So how can I make this better than that? And that's when we came up with serverless or on-demand. So tonight I'm actually going to be checking into a hotel. Everything's set up for me. It's got shampoo, got toothpaste, all the beds like pressed for me. I can show up whenever I want, and I'm only paying for the single night that I'm there. It's the exact same thing with serverless. You're only paying for the exact uses that you have, and all these server configuration is taken care of for you. And so it's a lot better because there's no setup required by you at all. It's just there. It's a lot faster because it's always ready. And you're only paying for the execution. So you're only paying for the single night in the hotel or per execution of the function. So if we go back to our overview, we can see as we went down each step of the hosting continuum from left to right, from home construction to hotel or from data center to serverless, all of our systems got simpler, more agile, and more dense. And what this allows us to do is to focus on the business value that we're providing to our customers and not the infrastructure underneath. So going back to our definition, cloud-native technologies help businesses build modern software that delivers a good and/or service to their customers. These technologies create better systems that allow engineers to make changes faster at lower costs, as we just saw. Great, so now what you all came for, Kubernetes, the cloud-native operating system. So how do we explain this in the same way that we just explained the cloud-native ecosystem? So with enterprise IT, we're not just doing a single software application or a single server. What we're doing instead is hundreds, maybe thousands of software applications, hundreds or thousands of servers, and how do we manage all of that? In the same way, a city doesn't just have one person in one house. It has hundreds, thousands, millions of people and hundreds, thousands, and millions of houses. And how do we match those resources to one another? So as we were saying before, Kubernetes governs cloud-native IT, and a city governs the housing market. So going back to the original definition of Kubernetes, we'll be breaking this down each piece by piece to understand what each component means for our better, faster, cheaper analogy. And we'll be building up the stack from the bottom, Kubernetes, all the way up to our software applications, from our governor of our city all the way up to the people in it. So starting at the bottom, Kubernetes, or the governor of the city. So Kubernetes provides declarative configuration and automation. And so to explain this one, I'm going to go back to the definition of a problem. So a problem can be defined as any situation when a gap is perceived to exist between what is and what should be. And to solve this, we need a process called reconciliation between the actual state and the desired state. And so this is exactly what Kubernetes does with declarative configuration. So we have a scheduler and a controller. If there's a mismatch between the actual state and the desired state, there's a reconciliation loop that brings them back together. So in the same way, in our city, if you're having a problem, you can talk to the mayor, and he'll look at the city plan and be like, okay, this is what we actually wanted to have. And he'll talk to a builder and a regulator, so the regulator will check what is our desired state. If it doesn't match, then we'll change it. So in the same way in Kubernetes, we have our etcd, our API server, our scheduler, and our controller. And that gives kind of a loop to bring declarative configuration to our city or to our IT infrastructure. And so it's better because we have a plan of what should be, and we can bring it together. Kubernetes does this automatically, so it moves it from manual time to computer time. And that's also a lot cheaper for us. Now the next layer is kind of the land or the actual infrastructure that we're building on. So whether it's bare metal or any cloud or where we want to go. And so Kubernetes, the great thing about it is that it's a portable platform. So it's not just tied to one single place. So a city can be built anywhere in the exact same way Kubernetes nodes can be run anywhere. So whether that's any public cloud that you want, any private cloud that you want, or any edge device, Kubernetes works wherever you need it to go. The same way we can build a city, whether it's in Antarctica or it's in Europe. And the advantages of this portable platform is that it's the same anywhere. We can take it wherever we need it to go. We don't need to change based on where we are. It's faster because you don't need to reteach your people the same tools over and over again. And it's cheaper because you're not locked into one vendor. You can move from vendor to vendor as you want. Next part, now that we have our land to build our city on, we need our city services and kind of our apartments, homes, and hotels. And so Kubernetes manages workloads and services on top of our infrastructure. So what does that actually look like? As we were saying before in our housing example, we have a mixture of different things. We have apartments, we have hotels, we have flat shares. And it's the same way. The great thing about Kubernetes is it's not just limited to one type of workload. It can run VMs, it can run containers, and it can run serverless workloads all on the same platform. So in the same way a city governs all these different types of housing all in one thing, Kubernetes can manage any type of workload that you need to run all within one platform. So what does that do is it allows us to have consistent abstractions across all these infrastructure. You don't need to learn a tool for every single one. It's a lot faster because you don't need to context switch between, okay, now I'm working with the VM, now I'm working with that. And it's cheaper because you're consolidating and streamlining it all into one platform. Think if you had different city government for every single apartment, for houses, and for apartments. Like, that wouldn't be as efficient as managing housing all under one government. And the last thing is the people on top, or the software applications on the actual infrastructure. And so what Kubernetes provides us there is that it's extensible and open source. So whatever you need to do with your cluster, you can basically find it in this landscape. In the same way, lots of cities have different requirements about what they want. Larger cities or large enterprises may have more things like malls and hospitals and churches, whereas like smaller cities or smaller startups may only have a few of them. In the same way, Kubernetes allows us to have flexibility to integrate whatever we need to, whatever we want. So a lot of people are going to have CI/CD, but maybe not every single company needs a service mesh on top of that. But Kubernetes provides a flexible platform to integrate whatever you need to on top of it. And so this provides you the choice and flexibility to only integrate the components or the complexity that you need for your business. It's a lot faster because you're not waiting for a vendor. It's open source and you can contribute to it. And it's cheaper because you can decide whether you want to build something or whether you want to buy it off the shelf. And so you can optimize for what's best for your business. And so how do we kind of consolidate all these things into one learning? So how do we explain what these business benefits actually are? So how do you take this to the C-suite? Well, first you need to start with a problem statement that like really scare them. And so you're like, okay, 91% of companies are using like this hybrid and multi-cloud thing, but you know, most of them are actually having a problem with the complexity of it. And to solve this, some people use orchestration, but like very few are using the automated orchestration and all these benefits that Kubernetes actually provides you. And so what happens if we as a company go to automated orchestration? What can we do? Well, it'll bring us to the new world of IT. In the old world, we were locked into a single vendor. We had really slow IT cycles because we were waiting for the operations team with this ticket-based cycle. It was super resource intensive because we didn't have consolidated infrastructure. We had costly downtimes to our infrastructure, and we were really like dependent on a single cloud provider. But now, if we move to this new world, we have continuous freedom of choice. So we're not locked into a single vendor. We can have a self-service platform that really empowers our developers to go and accomplish their work. By automating the operations and consolidating it into a single platform, it really speeds up the process for us. We don't have to worry about downtimes as much because these are highly available systems that self-heal themselves. And the great thing is we can dynamically move workloads as we need based on price or whatever other factors we need. And so what does this actually look like? If we can move our management from a VM-based system to a container-based system, if we can run all of our, instead of like clusters as VMs, we can run them as containers, well, we can save like $100,000 a year. Like, this is just compute prices off Amazon. And these actually like, okay, $100,000, like decent. Well, what if we can, through this automation, actually reduce the amount of human-intensive time that we need? So we're changing this from human time to computer time. What if we can reduce our number of people that we need to manage our clusters from 4 employees down to just 1 employee. Well, now we're looking at like over $500,000 in savings. And they're like, okay, this looks really good. So we're simplifying the management. Last part is, what if we can help eliminate those downtimes? Just 1 hour of downtime costs our business on average $300,000. What if we can eliminate that today? Taking all these things together, we're going to save $1 million a year. And what does that look like for the management team? That's how I'd explain the business benefits of Kubernetes. Thank you for coming today. I'm Bill Mulligan. I work at Ludsa. We're hiring remotely, so if you want to talk to me afterwards, feel free to. So, thank you.
So I have a question, actually, how to explain the transformation from, let's say, whatever legacy to Kubernetes when you have already the bot infrastructure, right? I mean, this overlap cost. Do you have any like smart ideas? You know, when you have to pay double or triple for whatever you have, and then for the transformation time and period.
So let me see if I can rephrase your question. So you're asking, how do you go about digital transformation if you're going from kind of legacy systems to a new Kubernetes-based infrastructure?
You have already the legacy system that you pay for, right? You have the maintenance costs.
Yeah.
And how do you explain, you just have to go through over the time it will be cost beneficial, or do you have any better arguments?
So what we've found working with our customers is like, first, you want to like start with kind of like a simple project so people can actually see, they call it like a quick win of like, this is kind of like the first step of like showing if we migrate this like simple application, look at what benefits this is providing us. Like, okay, we can run it on like half the infrastructure. We don't have to spend like half the time managing it because it's like self-healing. And we're like automating the process for our developers. So if we just do this for this one system and we can show that in like this small project, I think the problem a lot of times is people like, we're going to create a massive transformation, and that's not really how it works. You need to be able to like demonstrate in a way that people can like realize. So like all of these numbers, it's like, it all started with like a small example. It's like, okay, if here's like 1% of our infrastructure, and if we can get these benefits on 1% of our infrastructure, what happens if we can multiply that by 100 now? So creating an example product that's actually real world and goes into production to show what the benefits actually are, not just in this abstract thing of like numbers on a PowerPoint slide, but something that actually works in production at your company or at whatever else, show what those benefits are, and then saying, okay, now we know what the benefits actually are for our company. What happens if we scale this 100x? What does those benefits look like then?